So good afternoon, everyone. My name is Raquel Ribeiro. I'm from FCT, which is a Portuguese funding agency for science, research, and technology. So welcome to this wonderful ocean stage in this one-of-a-kind space of the Pavilion of Portugal. We are just side by side with the UN Ocean Conference Blue Zone over there, and where the main theme of discussions is scaling up ocean action based on science and innovation. So for implementing SDG 14, science and innovation. That's why we are here today, actually. So in this next hour, which is today's Science Hour, we have 5 fantastic speakers that will showcase what their respective institutions have been working on. The idea, as you know, is to have pitch presentations, meaning that each speaker has 6 minutes to get everyone hooked, right? So I'll be kind of strict about time. I'll send you a small signal when you have kind of 1 minute left to go to wrap up. If we have time, I believe we will. In the end, I'll open the floor for questions from the audience. So let's begin already. We are looking forward to hear you. So first one, let's begin with the importance of integrating data, and we have a lot of it. Our first pitch is on multi-source modeling of the ocean, coupling Earth observations with acoustic waves. And to present it, we have Leonardo Azevedo from CERENA. Leonardo, the floor is yours. Thank you.
Well, thank you all. It's really nice. It's a pleasure to be here and being able to share some of the work that we have been doing in CERENA along with other institutions under this scope. So today I'm here to share with you some preliminary results on the main idea of this exploratory project that is called multi-source modeling of the ocean, where we are trying to couple Earth observation data with acoustic waves. I should mention that this is not a project exclusively from CERENA, but is funded under the UT Austin Portugal program. So UT Austin is a partner of the program, along with the Faculty of Science from the University of Lisbon and also the Collab Atlantic plus Atlantic. So the main idea here is that we try to create a model or a modeling tool that integrates and lives in the intersection between two main disciplines: oceanography by one end, geostatistics or spatial data science, and geophysics. Okay, so everything starts from a picture like this, which is some seismic data that we acquire on the ocean, where we can image the structure of the ocean. So which one of these blue and white spatial features represent an interface between layers of the ocean with different with contrasting acoustic and temperature and salinity. So basically this data is acquired with a vessel that generates an acoustic wave field within the water column, and then this wave field propagates downwards and then is reflected back to the hydrophone array, or if you want to call it, some microphones that are deployed and towed by the vessel to record the reflected signal on every time that we have a variation of speed. So this is not new. This is the first paper is from early 2000s or late 90s. And what is very nice about this data is that we can have a long profile, hundreds of kilometers, but where we image, we have a spatial scale of about 10 kilometers or ranging between 10 to 100 kilometers in space. So we can see oceanographic phenomena at a very fine scale, scales that are very hard to sample with conventional oceanographic casts. So this is not new, but what we try to do is to push this data into something that is more useful for oceanographers. So in this image here, we have the exact same vertical profile. It's like a cross-section of the water that we predict the spatial distribution of temperature and salinity from that geophysical data. So basically, the vertical lines are direct observations, are oceanographic casts, vertical direct measurements of the water properties for temperature in this case, and then we kind of interpolate, is an educated guess with the geophysical data that I demonstrated before. So this is what we do in CERENA, and that we've been doing in the development of these techniques to solve what we call an inverse problem. And basically, We are applying it to the shore of Portugal. I bring you a very small application example from the Madeira Abissal Plain. This is data that was acquired by the EMPC and that was provided to the development of this project. So it's three vertical profiles acquired by, located in those red lines in the map in the top left corner of the image. And then the three profiles after processing, so we don't acquire the data, but we process the data. We can see structure in the ocean. And as you can see, they are apart from each other, they are parallel from each other a few kilometers apart. And the idea of this project, or the main goal of this project with the intersection of these three disciplines, is to create a three-dimensional model able to image and model those scales between 10 kilometers to 100 kilometers by coupling the vertical profiles acquired by the geophysics that are represented there, coupling large-scale climate or reanalysis oceanographic models to provide the trends and the large scales that are unable to be captured by the geophysical data, and then some satellite images to in somehow using or leveraging spatial data science methods to create a three-dimensional model of a region of the globe. So we would have like a snapshot at a given time for a specific location of the ocean at the scales that are very hard to sample and very expensive to acquire by conventional oceanographic casts. So that's basically our idea. We are not only studying Madeira, but also we have plenty of seismic profiles along the west and the southern coast of Portugal. And basically, I would just like to acknowledge the funding institutions, FCT and the UTS program, which are funding this project, and I'm them, and we can discuss later on. Thank you.
Thank you, Leonardo, and thank you for keeping us on time. That's thrilling, integrating data to have more ocean observed, and because we need a lot of it, it's a big ocean, so a lot of data. Yes, the next pitch, let's go on, is presented by Paulo Mónica de Oliveira. He's from Tech4C Infrastructure, which is a research infrastructure integrating the national roadmap of scientific infrastructures funded by FCT, and that tests ocean technology solutions. Paulo, the floor is yours. Thank you.
Hello, my name is Paulo Mónica and I'm with INESCTEC, and I'm here to tell you about Tech4C. It's a platform that we have been building up in the last 5-6 years and which is now entering the operational phase. So let me start with the why. Why Tech4C? Why did we feel the need to create this platform? And to try to answer this, I will start with difficulties of doing business or science at sea. Some of these difficulties have to do with licensing and regulations, but some have to do with resources and technology. To operate at sea, we of course need very expensive resources, expensive to acquire, expensive to maintain, expensive to operate, and we also need very specific and also expensive technology. Additionally, we of course need to have the know-how. It's a very unforgiving environment, and therefore you need to have the expertise. Because of this, as we all know, there's always a high cost of doing either science or business at sea. So what can Tech4C do to mitigate these problems? And well, we can't do much concerning licensing and regulations. You still have to go through these, of course. But we can help you with all the rest. We do have a vast, broad and eclectic set of resources and technology, from just lab equipment to several types, shapes and sizes of robotic platforms, air, surface, subsurface, unmanned, manned, autonomous, non-autonomous. We have the test tanks, the hyperbaric chambers, the bottom landers, the seagoing vessels. So we have it all. But more importantly than what we do have is the fact that we can always develop customized technology for whatever purposes are in hand. In fact, we do exist to develop new technology. We also have, as of now, a very knowledgeable and expert team. Our main areas of expertise are in robotics, maritime communications, sensor development, and underwater acoustics. And by making this set of resources and know-how available to you, we can, of course, stop the need for you to have your own expensive set of resources, and therefore we can mitigate the costs of you doing either business or science at sea. So this is the why, it's also the what. This is a description of what we can do. So let's go for the who now. And all I have is two main ideas. Idea number one, we have been created and designed to develop new maritime technology. We do it all from conceptual development through prototyping, testing, and mission deployment. So that is idea number one. We exist to develop new technology. Idea number two, we are an open platform. That means that whatever we can do and whatever we know how to do is available to outside communities to use. In fact, we have been created with three defining objectives, so they are part of our DNA. We are supposed to support the external R&D community. We have to support the external industrial sector. And finally, of course, we have our own agenda and scientific roadmap, and so we aim to push the envelope of maritime technology. This support of the external communities is basically done by making available whatever facilities we have, our resources. We can provide support to seagoing missions. We can, of course, provide turnkey services. We can transfer know-how, and we can carry out advanced training actions. In our portfolio, we nowadays have many services available. This is just a handful of them, from fast and easy access to deep sea to design and fabrication of autonomous vehicles, again, customized for whatever mission is desired, to underwater surveying and mapping, to maritime communication systems developed, etc., etc. All these services can be provided in one or more of four different typologies. If you know exactly what you want to do and exactly how to do it, and all you are missing is access to some piece of equipment or some resources that you do not have and we do, then we can just give you supervised access to our own resources. But if what you do require is technical support, that's fine, we can do that, of course. We can, as I told you, do specialized training and or provide turnkey services. So, we do exist. We can provide a full spectrum of services, from access to resources to turnkey services. We can help you develop customized technology for maritime, well, aquatic environments. And we can therefore and thus reduce your costs of doing either science or business at sea. And this is it. Thank you.
Thank you so much, Paulo. Many times we say that the difficulties of doing ocean science, ocean research, going to the sea is so difficult because we do not have infrastructures. That's excellent to have a Tech for Sea.
Exactly.
Yeah, exactly. Thank you. Well, the ocean is wide, as we all know, and robotics is valuable to increase our knowledge of the marine environment. Our next speaker is Antonio Pascual, and he will present us the pitch Opening the Blue Frontier with Marine Robotics, Science, Engineering and Society, and explain a little bit of the work LARSYS has been doing. Thank you.
Okay, good afternoon everyone, it's a pleasure to be here. I have a tremendous task because I have to show about 26 slides, but we'll see how it goes. Anyway, now notice the title, Science, Engineering and Society. We are at the University of Lisbon, so our task is to develop new concepts and new prototypes. Okay, so we are in the business of developing robots to move, observe, and act upon the environment, and to try and bridge the gap between theory and practice. It's extremely important for us. Now, this is, of course, the work of many, and here you see some of the pictures of moments of pleasure with many people at sea. We have the infrastructures available. In fact, some of them are right out there. That's where we carry out some of the tests. And I'm going to give you some highlights of the work that we have been doing over the years. So one of them has to do with seismic surveying. And you described this rightly so well that I'm not going to get into it. That's the classical approach. In the context of the WEMAS project, we developed a fully robotized system for seismic surveying, whereby you have actually we ended up two surface robots with acoustic sources, and then a bunch of vehicles underwater carrying the hydrophones and the streamers to acquire the data. So we developed, together in the context of this European project with many partners, the autonomous parkers and multiple vehicles with streamers, thus forming an adaptive antenna. And this is a sight to see. It gave us great pleasure when you had all these 7 vehicles in the water. And at the end, what you see, this is an image from a quadrotor. What you see is very interesting, because if you could touch this movie, oh, you are not there. If you could play the movie, okay. This is a beautiful 3D pictures obtained by geosurveys that based on data, on seismic data. They actually animate what is it that you can see underneath the seafloor. That's the kind of image that you get. It's fantastic. Now, of course, we developed another system to do seismic surveying in very shallow waters, and this is our vehicle equipped with a streamer and with streamers and an acoustic source, and we did the first commercial survey near a nuclear power plant in France in 2020. We have also engaged in the development of hybrid systems that can operate both as ROVs and AUVs, and this is a beautiful cooperation with a company in the US called Strategic Robotic Systems that led to the development of the vehicle that we have out there in our booth. Recently, we started this FCT project on radioactive mapping of radioactivity underwater, which is a very difficult task. And this started about 1.5 years ago. We are going to use one surface robot and 2 underwater gliders plus a benthic station equipped with sensors to measure radioactivity. And you can think of all kinds of problems that pop up because the vehicles have to communicate with each other, do what we call adaptive ocean sampling, decide when to sample, where to sample, how to coordinate their motion to obtain a map of the seabed. And these are all the concepts that we have to bring into place in order to make this work: control, navigation, and motion planning. The final test will take place in Santorini, in Greece. So that's the web page for the project. So finally, I would like to show you something that has to do with something completely different: ocean literacy, empowering the people with the capability to see what is happening underwater and actually taking control of a vehicle underwater, not actuating on the thruster, but giving high-level commands. Go to the right, to the left, up and down at a certain depth. So this we finished together with our partners in Italy, and therefore you can have people in the classroom or in an amphitheater looking at images that are broadcast from the ROV. For example, you see a beautiful example here where we did a dive in the south of the Algarve on top of a sunken ship. I think this will be animated, I hope. Now, this is 10 times, so you see the details of the cannon. Some of these pictures were captured by an operator that was in Italy, actually commanding the vehicle and looking at the pictures. You see the cannon there. Now we are going to look at the steering wheel. I hope it's the name that in the Navy, the correct name, I don't know. So very exciting stuff. And finally, an operator in Genova that was actually piloting the vehicle, again, not controlling the motors, but giving high-level commands. So this opens the path for what we call ocean literacy, making the ocean available to the common citizen. There you go. I don't think there's a video here, and this is from the office in Genova, commanding the thing off the coast of the Algarve. So I'd like to end with a very positive note that has to do with the education. So we are engaged in an Erasmus Mundus project on marine and maritime intelligent robotics, where we managed to bring partners from across the world. And the first year is essentially over, and we got fantastic studies for students from all over the world. So it's transitioning from concepts, theory and stuff, and injecting all this knowledge into young blood that hopefully will influence the future. Thank you.
Thank you, Professor Antonio. I think you've mentioned there a very important aspect about doing some research in the ocean, which is cooperation with within many countries. I believe that's key to set some goals and reach them.
We can talk about that.
Yeah, we can talk about it a little bit later. I'm now going to pass the floor. So ocean biomedicine, kind of it, right, is the topic from the next and thrilling pitch entitled Marine Biomaterials in Biomedical Applications as New Therapeutic Solutions. So to present it, please welcome Tiago Silva from the 3Bs Research Group from the University of MINHO.
Thank you. Thank you, Raquel. Thank you all for coming, and I'd like to start by thanking FCT for giving us the opportunity to share a bit of what we are doing. We are working on the crosstalk between the red and the blue biotechnologies. So we are coming from the University of MINHO, so also from Portugal, but from the north part of the country, and we are a research group located more or less between two historically important cities in Portugal, Braga and Guimarães. We are within a technological park, and we are also the headquarters of the European Institute of Excellence for Tissue Engineering and Regenerative Medicine. So we are about to expand our facilities, so we are about to double our facilities included in the national roadmap for research infrastructures. So basically, we work generally in regenerative medicine, and this is a very multidisciplinary area. So we join people from many different backgrounds and many different origins as well. And a part of it works on blue biotechnology. So on blue biotechnology, we are looking for the marine biological resources, and we all know, we are all here actually, if you recall the name of this event is One Sustainable Ocean, so the sustainability is a key word in here. And so we are trying to work to promote the sustainability of marine resources. One of the ways we think we can do that is to increase the use of the resources, and namely looking to different byproducts for the processing of these resources, or looking to underused resources to better know the biological resources in our oceans, and better knowing them, we can preserve and use it in a more smart way. And so with this in mind, we have established together with many research institutions and companies first in the north of Portugal and Galicia in Spain, but then expanding to the Atlantic area of Europe, this network on marine biotechnology entitled Multipolar Center for Valorization of Marine Resources. In here, our idea is to look to these different marine resources, including byproducts, as sources of materials, and materials that we can then use in different applications. And so in this regard, we can, for instance, look to byproducts from the fish processing industry, like fish skins and fish bones, and we can obtain materials from there. We can obtain collagen, that I'm sure many of you have heard for cosmetics. We are be able to obtain also gelatin and ceramics like calcium phosphates. But also we can look to byproducts from other origins, from other resources, namely from crustaceans and cephalopods. So from crustaceans we can produce an important biopolymer, chitosan, and this can be obtained under a biorefinery concept. So not only producing chitosan, but also looking to opportunities to use the other components of this raw material. And the same can be done with the endoskeletons of squids, for instance, the squid pens. And besides, even from algae, we can also obtain many different compounds, and we are looking particularly for a specific polymers from these algae. So why we are using and why we are needing this. So the isolation of compounds is not enough for the valorization of marine resources. We need to give an end to these materials. And these are having many different ends, and we are exploring particularly their application in regenerative medicine or in tissue engineering. So in here I need just to give you a quick overview of the idea. So nowadays the medicine is a substitutive medicine. So if you have a kind of a lesion for an accident or a disease and you lost an organ or part of a tissue, like in an accident, you'll receive a prosthetic material if there is any available. We believe that it is possible to change the paradigm to a regenerative medicine. So we can see that in many organisms that they are able to regenerate part of the bodies, and we believe we can do that also in humans. And so the strategy is to use cells. Cells are basically the basic unit in here, to cultivate them in these those polymeric three-dimensional structures, and to create kind of in vitro tissues to implant in the body and regenerate the tissues in that direction. And so we are doing that using those materials that I've mentioned. So we are developing different kinds of structures and hydrogels using those materials and many different technologies. So for instance, we can even use collagen and use the now fancy 3D printing technologies to produce structures in using collagen. And also developing other kind of structures that are quite relevant for the biomedical industry. So basically, what we are trying to do by combining marine organisms and the efforts of scientists and clinicians is not really to develop this kind of chimeras, even if they are, or they can seem attractive, but also to contribute to a healthy society. If we will be able to it, so I believe the future will tell, and I need to acknowledge, besides your attention, also all the ones enrolled in these and also the funding. Thank you very much.
Thank you, Tiago. That was quite exciting, and I very much appreciate you didn't mention the term, but circular kind of economy there.
Exactly,
so very
exactly.
interesting indeed.
Exactly.
So our final pitch today is given by Diogo Neves. He's from INEGI, an Institute of Science and Innovation in Engineering that runs lab tests that also contribute to the sea economy. Let's learn a little bit about it. Please, Diogo, take the floor. Thank you.
Hi, good afternoon. Thank you for coming. I'm Diogo Neves. I do represent the Institute of Science and Innovation in Mechanical and Industrial Engineering. Our institute works mainly with the companies and with the industry to make the bridge between the academia and the industry. For that, we have three pillars. One pillar, research and development, that works more directly with the academia, and innovation and technology transfer that grabs the innovation and the science to build more atypical solutions that the companies and the industry needs to overcome the challenges of these days. We also have a services pillar for more typical services. We have 272 qualified people. We are located inside the Oporto University campus. We also have offices in Évora, in Turkey and Brazil. We work with many clients from several sectors, from aerospace to aeronautics to automotive, sea, health, etc. Because we are organized by thematic areas that need the mechanical engineering and industrial engineering expertise. So we have a product development area that creates a product, simulates, generates scenarios and tests, additive manufacturing unit, manufacturing processes, composite materials, also materials that are sub-products of the industry. We work with that, we reuse materials, we manage to build new products that are more sustainable for the climate and the ocean. We also have an energy department just for renewables and hydrogen, circular economy studies, LCA, etc. So the main core is that we have these laboratory facilities and we can prototype with our additive manufacturing unit and manufacturing processes. We can prototype until the final product of the company, the pre-commercial phase, and then with manufacturing processes studies, we can give that knowledge to the company for the company to commercialize their products. So we are more interested in innovation, in outstanding developments that goes to the state of the art or beyond the state of the art to deliver solutions that are not available in the market at the moment. So just for you to have a portfolio of some applications that we did in the sea economy, we are in this Mare Wind project, European project, where we develop monitoring processes with drones for the wind blades or the offshore windmills. We also developed monitoring processes for the subaquatic area with sensors and also algorithms for the predictive maintenance of those structures. We developed tanks for microalgae aquaculture, characterization of the behavior of floating offshore wind turbines. We are now in this project FiberG to substitute some metal parts that are corrosive into composite materials that are more sustainable for long-term, long applications for the offshore wind turbines. We were with the INESCTEC in this project developing a docking station for AUVs to transfer energy and data. This project where we developed solutions for renewable energy inside breakwaters. We also developed experimental methods to measure the drag force for ships. We designed, and it's building not right now in the warehouse, this unmanned offshore vessel patrol that has an hydrofoil system that is able also to harness energy from the hydrofoil system. This rebreather for the diving as backup in case of the failure of the equipment. We hope not. Observation stations for the subsea, for the seafloor. Also in this project, Protevs, it was a finalist from the European Innovation Awards this year, where it developed a modular solar island that is able also to follow the path of the sun, and also a nanotechnology wave energy converter for a wave buoy. Thank you very much for your attention. We are very pleased to address all the challenges of the industry regarding the sea economy.
Thank you, Diogo. You talked a lot about different projects, really. I was hooked by that fact of making wind turbines more sustainable along the time, because that's starting to be an issue, what to do with dismantling wind turbines, what to do with them. So it's trying to extend their lifespan is really important, right? So thank you. Well, the first difficulty of my job is done because you were all excellent in keeping on time, so thank you for that. Which opens us time for questions. So please, from the audience, I hope you have been hooked as I have for all these projects, and please, we have some assistants there with the microphones, so please, if you have any questions, pose them. Thank you. You're all shy a little bit, right? Yes? Okay, we have one. Please present yourself before speaking. So
Okay.
we can only, yeah.
My name is Luís Sebastião from IST, Institute Superior Técnico, the School of Engineering here in Lisbon. I will address the question to Leonardo, my colleague at IST. It's fantastic images and models. When we talk about models in our area, we usually talk about dynamic models. And as you said, we're talking about snapshots. So my question is about the 4D, if you want to call it that way. What plans do you have about that, or is it too difficult? Maybe robotics can help.
So
That's my question.
thanks, Lucian. So that's a very good question. So we are not yet looking at how to integrate these snapshots, these static models in the dynamic ones. Kind of the obvious way would be to include them as initial state conditions or background conditions for the full physics models. Okay, so that's one of the key points. What we also think about is that these models, they do show oceanographic features that are not captured by large-scale models that can help some constrain the physical model themselves. So that's something that we are trying to pursue, not exactly in this project. This project is only related with the statics, but then in the future in the research lines that we have. Okay, so obviously that's an obvious question. An alternative way would be to acquire geophysical data over time, as you mentioned, and for that, I'm pretty sure that robotics will help in acquiring the data and sampling or digitizing the ocean, if you will. So that's something that obviously we are looking at and trying to gather collaborations. I would say. Thanks.
But okay, thank you everyone. Any other question? So I would like to ask one because, as you know, I'm from FCT. I'm on the side of the implementing public policies, as you know. So it's really for all of you, maybe. I would like you to, well, we know all how important it is to narrow the gap between what scientists and technology does and what we implement as public policy. So, and as we are in this ocean environment this week, my question is, how do you find your work useful, or what would you highlight in your work that is useful for tackling ocean problems, for addressing SDG 14, addressing the ocean decade for a sustainable ocean? So please, I'll start with you, Leonard, as you were the first one to speak, please.
All right. So again, I should say that this is just one project that we are doing in CERENA. So we are dealing with the ocean, different perspectives in the full institute, not exactly on my team, but on the institute itself. Specifically with this project, what we aim is really providing new insights regarding the small scales that are unable to capture. There is a recent paper in June from Nature that just mentioned that one of the keys to explain climate change can be hidden in the small scales that are not properly sampled. And this is exactly what we are trying to aim, is to provide new information, relevant information. And something that I didn't mention yet is that most of this geophysical data is already available in our oceanographic basins. Okay, so there is efforts from governments and the industry that acquire this data, and the data is there, but is not used because most of the times, or traditionally, this data has been used to image the subsurface. And this is just a new perspective, a new source of information, or if you wanted to put it like that, just a new window into a reality that we truly do not know. So
Yep.
that's our contribution.
Yeah, but that's interesting. The data is already there.
The data is already there.
Just take the information.
Yeah. So data is there. It's just a matter of process the data, develop the methods, and leverage the data that already exists.
Yeah. Okay.
Thank you.
So I'll just stick with. Oh, sorry. I think. Do you hear me? Yes. Okay. Sorry. I'll just stick with this line. Antonio, please, if you would like to say what.
Can you hear me?
Yes. We
Okay.
do.
I will focus on the environment because we are very much interested in other topics like energy and food and things of that kind. So environment, we are quite excited about this Ramones project that has to do with mapping radioactivity in the ocean for a number of reasons. There's natural, there's man-made radioactivity, and to my amazement, this has never been done before. The problems are staggering. For example, if you have a source, gamma radiation, probably you can detect it in the water if you are at most 1 meter away from it. So how in the heck are we going to find that needle in the haystack? Okay, there are ways around, but it's very interesting. So it's one thing that we are focusing on very much, the environment. We just finished submitting a proposal, and this one also is related to the environment, and the title was to develop new technologies to assess biodiversity. And it's amazing the kind of work you have to do that. We really have to develop a new breed of vehicles that can cooperate. You should be able to leave them out at sea without chaperoning them constantly. And then being able to acquire data, roam the oceans, decide when to acquire data. It's wide open. It's totally wide open. So these two areas of interest, we will pursue them very much. And then the other areas, of course, ocean literacy, that we are very keen on pursuing.
Yeah, that was quite interesting.
Yeah.
Do you think we are quite there with, putting robotics and getting the variables from the ocean quite...
I think we have to break with what is classic. So what is classic? Go out there with a big ship, with a big crew, you deploy your robots, and then you wait and pray for them to come back. Now you have to reach the stage where you trust the systems and you leave them there for weeks, months, and stuff like that. So you need energy down there. Yeah, the thing you were talking about. Energy harvesting is going to be extremely important, and the capability of sustained autonomy at sea for these vehicles to be able to be there for extended periods of time. We are not yet there.
Yeah. But I think, well, I don't know if you agree with me, but with the occupation of the ocean, with ocean planning and management, we have infrastructures for energy, and we can use them also to put some, sensors and robotics and technology to get more information. That's what we are trying to do with the submarine cables for telecommunications. Which is, I think, we are going to go on that line very briefly in time. So, but that's it. Try to use.
We have to break with a classical approach.
Yeah. Thank you. So the same question, Paulo, for you.
Can you hear me?
Yes.
Okay, I have an easy answer because we are a step back. We are not going to solve any of those problems. All we want to do is to develop the technology that will then enable some people to solve those problems. So we are working one step back. Additionally, by making whatever we have and we know available, we intend to be honest in advancing in both science and business at sea.
That's interesting because in the mission Ocean from the Horizon Europe that we have right now running from the European Commission, in the mission we have those problems we want to solve about marine pollution and everything, and then we have, it's not separate, but another type of actions which are the enablers. So you are an enabler, what you do, right? Yeah, that's it. Which is really important, that's why it's being tackled, Tiago, the same question for you.
Well, I need to speak, of course, about the biological resources.
Yeah, of course.
We work on that not alone, but I would say we work in two perspectives. From one side, to know better what we have. So there are people saying that we, as a society, know probably more about the moon than we know about the ocean. And that is probably because we were not investing so much on going to the ocean. So we have heard our colleagues talk about it. So for me, if I start to have water by the chest, it's already too much water. Some of you are probably diving. But come on, after a few meters, we cannot go there without any heavy equipment. And we know that the sea can be really deep. So there is a lot for us to know, including on biological resources. And then by knowing to use them in a more sustainable way. And we have been doing it that very badly, because we were raised in well, at least my generation, in that generation of using part of the resources and throw it away, and if I need more I go and collect a new one. I don't gonna look to the other. And even on the sea we have partially a good example with the whales. When people were collecting whales, they were using every tiny part of the whale. The bad part is that they were collecting all the whales that they were seeing, and that was the bad part. And so we are now trying to learn, and we are trying to contribute with us with our work to that goal, to show that we can get a lot from the resources, but we need to do it in a sustainable way. Otherwise, in the future, people will not be able to do it.
Yeah, exactly. I fully agree with you. Yeah. Diogo, so please, the same question to wrap it up.
Well, I just want to say that the biggest incentives are the goals of the European Union, the goals of the United Nations also. That's the carbon neutrality by 2050 of the European Union goals and the United Nations are the main aspect that leads the industry to develop more ecological solutions, and we are working with the industry, so that's our goal to meet those political targets.
Yeah, that's good. A little bit of top-down, of also oriented work that you do in a lot of areas, really, INEGI.
We have a department of circular economy, etc., that works in designing these products more eco-friendly as possible.
Yeah, wonderful. Yeah. Well, we do not have a lot of time. This went very quickly, but I think this hour was definitely worth it. I don't think we do have a question. Yes, so please.
I'm sure everyone's aware of plastics in the ocean having leached their way through the ecosystem and into the soils now. As far as where you're concerned individually with your industries, how much of that aspect are you taking into consideration in your planning to try to reduce that level of toxicity? I'm in the health and wellness, so basically I'm working on formulations that will help to detox the physical body, the human body, of plastics in the form of phthalates and so forth. And the estimate is that every single human being today has the equivalent to around 4 credit cards worth of plastics in their bloodstream. So just a simple question, but I'd be curious to know how much of that particular aspect are you taking into consideration in the planning of your overall objectives?
Does someone want to take it?
I can contribute to that, saying that tomorrow I'll be here again showcasing one of the projects that we have with the Portuguese Space Agency, not on the development of technologies to remove or to clean up the ocean, but on the development of tools to model and forecast the evolution of the litter and the plastic debris in the ocean. So that's our contribution, is not on the harvesting the plastics or reducing the amount of plastics, but in the development of tools that can be used by decision makers to act immediately as soon as the plastic enters the oceans. So that's our contribution in CERENA.
Okay, that's great.
Tiago, you wanted to say something?
Yes, I can also give another perspective. So it's not particularly our main focus, but our colleagues and some part of the work we have been doing as well, by isolating materials from marine organisms, we can produce the so-called bioplastics, and so things that can be biodegradable and eventually substitute the plastics with origin in oil that we know. And so we can contribute in that direction, but we also use lots of plastics in our activity, and it's quite difficult to change perspective. So is very much now in an individual approach, if I'm more sensible or not to that topic, but it's very difficult, and it's just by appearing something like we have now with the COVID, and we want everything sterile and single-use things, and all the objectives that we had for the plastics got destroyed because the amount of single-use plastics increased dramatically, and so it's very difficult to change.
Yeah, because the main aspect is that it's found its way into the soil. And I'm working with different organizations, including Satguru, because he's got this new initiative of Save the Soil. But the soil is leached with plastics. So it isn't just that the metals and the minerals have gone, they've had a lot of leaching as a result of evaporation from the oceans to the skies, into water, and then back into the soils. So we've created a system of toxicity that is pretty difficult to try to find an intervention. So I'm listening to what you're saying, which is all very positive in terms of your intervention, your innovation, and your existing intentions. And I'm trying to find a way to stop it at the source. Obviously, the best way would be to stop using plastics, but that's not going to happen any day soon. We have to find another level where we could use microorganisms to break them down, the plastics, at a faster rate than they are being generated. So I'm just listening to what you could possibly offer as a solution, because I know in our bodies they are not functioning anywhere near as well as they could because they are so toxic at the moment, and the plastics certainly contribute to that. EMFs are another level. I'm working on that with a different group of people, electromagnetic frequencies and the pollution. But plastics are certainly a very high contributor to the impact it has on our brains and the efficiency in being able to clean our own bodies, because it's causing a huge amount of exhaustion and contributing to the immune deficiency very rapidly.
Yes, well, that's really scary, and it shows once again that all it's connected, really plastic going into everything, right?
Yes, yeah. You can't escape it now, and I'm just curious to see if that's been brought into your agenda in terms of your sphere of work that you're involved in.
So thank you for that. I believe you and everyone else will have the opportunity to catch up with these wonderful speakers afterwards, or reach out through the institution emails. So please do if you got hooked. It was very interesting for me. Thank you so much. I would like to ask you a round of applause for our speakers, please. And also, I would like to acknowledge the work of FCT. I would like to acknowledge the work of Ana Morim. I think she was tireless with all the arrangements with you. Also Fórum Oceano, the Municipality of Lisbon, the University of Lisbon, our sponsors. And of course, thank you so much for attending. Please reach out to everyone if you really got interested in this. Thank you so much.